So we are the Ppms Maps team, and this year we've been studying different types of insulin analogs, which basically means modified versions of insulin that are designed to treat diseases like diabetes. So basically this year we've chosen to study the analog called 1UZ9. The chemical name is N-lithicolol, and this is a slow-release type of analog, which means it breaks apart in your bloodstream a little bit slower, which means that you don't have to inject yourself as many times, which is really bothersome. So I'm going to have Mia start talking about the structure of this insulin analog, N-lithicolol.
Okay, so within the structure we have 6 monomers. A picture is right here. So within the monomer we have an A chain and a B chain. Connected to the B chain there is a fatty acid called N-lithicolol, as Carrie said before. This fatty acid binds to the albumin in the blood, which is a protein. The disulfide bonds, those help stabilize its structure, which ensures our slow release, similar with the zinc here. The hexamer form also ensures our slow release too. And now on to Rudy.
Okay, so these are our results. We have 3 types of insulin: N-lithicolol, which is the one we have modeled here, NN304, which is an insulin that has been artificially developed by scientists, and human insulin, which is our natural insulin. Now, if you look at the top, it measures how well both artificial insulins bind to HSA, which stands for human serum albumin. And now, albumin is a protein in your blood, and the numbers mean that the greater the numbers are, the better the insulin binds to it. And in this case, N-lithicolol doesn't really bind as well to HSA as NN304 does. But if you look on the right, it measures how well all of the insulins bind to HIR, which stands for human insulin receptor. And this is very important because in order for an insulin to work, it has to bind to the receptor. If you're wondering, the receptor is a protein that helps the insulin signal the cells to allow glucose to come into the cell membrane. And in this case, N-lithicolol does a great job of binding to the receptor than NN304 does. But human insulin does a better job than both of them because it can be very hard to replicate the human body. Scientists have been trying and trying, but it's very hard because the human body is so good at doing what it does that scientists haven't been able to exactly replicate it. But for those suffering with type 2 diabetes, N-lithicolol insulin would definitely be a great choice.